Hi there, algebra fans. Mrs. Lindsay here, bringing you more about the wonderful world of parabolas, specifically vertex form. How to convert standard form to vertex form, and what good is it anyway? Let's look at some examples, shall we? Now here's a quadratic equation in standard form. And standard form is good for one thing, finding the y-intercept. So my y-intercept in this quadratic equation, or this parabola, is 0, -5. But that's about all I can do with standard form of a quadratic equation. In order to find the vertex of the quadratic equation, unless I use the axis of symmetry formula and then substitute my x back into the equation and find y, I would have to convert this to vertex form. And here is vertex form. If I had my quadratic equation in vertex form, it would be easy to find the vertex right from the equation. So my x minus h squared, I look inside the parentheses and pick the opposite of what's added to x. In this case, -h is the opposite. So I pick the opposite to get my x coordinate. And outside the parentheses, or what's added to the parentheses, is my y coordinate, and that is not the opposite, that's exactly the same. So inside I get my x coordinate, outside I get my y coordinate. But how do I convert standard form to vertex form? Well, I do it in much the same way I completed the square. So I want to get rid of this -5 because it's not the perfect square that I'm looking for that works with the 6x. It's not a perfect square at all. So this becomes f of x plus 5 equals x squared plus 6x, and now I put in my own perfect square plus blank. Now, in order to find that perfect square that I fill in the blank with, I use my box method. Some of you don't need the box anymore. You certainly don't have to use it. But if you do, the x squared goes in the upper left. The 6x gets split between these two sections, 3x and 3x. And that gives me x squared factors to x and x, and I have to multiply by +3 to get 3x. And 3 times 3 is 9. That is my perfect square. So I fill in the perfect square blank with 9 and 9 on the other side as well. This gives me f of x plus 5 plus 9, or 14, equals, and now here's where my box works out well. I have my factored form, x plus 3 times x plus 3, or x plus 3 squared. Now it's simply an easy case of subtracting 14 to solve for my f of x. And I have f of x equals x plus 3 squared minus 14. So, how does that help me? Well, first of all, this vertex form gives me the vertex. The opposite of the inside, or the opposite of the x coordinate, -3, and the y coordinate is outside, but it's not opposite, it's the same. So there's my vertex, -3, -14. I know that this parabola is concave up, because my lead coefficient is 1, which is positive. So my a is 1, and anytime your a is positive, you have a concave up parabola. So there it is, vertex -3, -14, comes right from the equation. in vertex form, and we know it's concave up because both lead coefficients in standard form and vertex form are 1. Now, what happens if we have a negative lead coefficient? Well, the first thing you need to remember, if your lead coefficient is negative, is your parabola, if your A is less than 0, is your parabola is concave down. So anytime your lead coefficient is negative, your parabola will open downwards. So your vertex will be a max. It'll be at the top. Okay? But we do have a problem writing this in vertex form because in order to write it in vertex form, we need that lead coefficient to be 1. So what we're going to do is divide everything by -1 in order to get that lead coefficient to become +1. But since we have f of x and not 0, that -1 doesn't simply divide out. We have to preserve it. And we do want to preserve it because we want to make sure when we graph this parabola, it is concave down. So the good thing is -x squared divided by -1 is x squared. The rest of the trinomial changes signs. 6x becomes -6x. 11 becomes -11. But we're not worried about that. We want our lead coefficient to be +1, and now it is. So we're going to add 11 to both sides to remove the constant that we don't want and replace it with our own perfect square constant. So this is going to look a little bit messy, but we'll have f of x divided by 1 plus 11, or divided by -1, plus 11 equals x squared minus 6x plus blank. And we're going to fill in our own perfect square with that plus blank and write it on both sides. Again, if you don't like the box, you don't need to use it. But we know that we have x squared. We need to split up this -6x, -3x, -3x. X squared factors to x and x. We have to multiply by -3 to get -3x. And we also know that -3 times -3 is +9. So that is what we're going to fill in our perfect square blank with. We'll have f of x over -1 plus 11 plus 9 is 20 equals, here's the great thing about the box, I now know what my factors are. X minus 3 squared. Now, we're going to have to do this one at a time. We need to solve for f of x. And the first thing we take care of is what's added to f of x. So I subtract out the 20. I'll have f of x over -1 equals x minus 3 squared minus 20. Now, here's the trick. When I want to get that -1 and away and solve for f of x, I multiply both sides by -1, but I need to multiply this entire right side by -1. So those ones will cancel out, and I'll have f of x, but this -1 will distribute to the squared binomial. Don't go inside the parentheses, just leave it on the outside. And you're going to have to distribute it to the -20. So you'll be left with f of x equals negative x minus 3 squared, and minus 20 times -1 will be plus 20. So here is my vertex form, and my vertex will come from the inside opposite, which is 3, and the outside, which will be the same, which is 20. So my x-coordinate is 3, my y-coordinate is 20, and here it is, 3, 20, concave down, so it's a max. Now, what to do if my lead coefficient is not 1 or negative 1? In this case, my lead coefficient, my A, is greater than 1. Well, again, I need to remove it so that I can write this in vertex form. But before I do that, let's talk a little bit about what happens when the lead coefficient increases. So here I have my red parabola where A equals 1. And you see that this opens up, so it's concave up, and it's of a certain width. But when I multiply everything by 2 in this blue parabola, w of x equals 2x squared minus 8x minus 22, my A is equal to 2. Not only did the vertex change, because I changed all the coefficients, but it became narrower. So it narrowed and it stretched. So I stretched it, and when I stretched it, it became narrower. So my red parabola was of a certain width, but my blue parabola kind of fit inside it and stretched and became narrower. So keep that in mind when we write our standard form to vertex form and our lead coefficient is greater than 1. So again, we need to remove that lead coefficient, and temporarily, dividing everything by negative 2, move it to the other side. So this will be w of x divided by 2, and all these terms are going to divide by 2. So I'll get x squared, which is good because my lead coefficient will now be 1, minus 4x minus 11. I'm going to remove that negative 11 because it's not the perfect square that I want to work with. That works with the negative 4x. So I'll have w of x over 2 plus 11 equals x squared minus 4x. And now I'm going to insert my own perfect square. So I'll plus blank, and I'll plus blank on the other side as well. If you don't use the box, that's perfectly fine. But if you use the box, you have x squared. I'm going to split up negative 4x into negative 2x and negative 2x. X squared factors to x and x. I have to multiply by negative 2. And negative 2 times negative 2 is positive 4. And that will be the perfect square that I'm going to insert to both sides of the equation. Now, here on the left side, I'll have w of x over 2 plus 11 plus 4 is 15 equals x minus 2 squared are my factors. And then one at a time, I'm going to solve this for w of x. I'm going to subtract 15 from both sides. So I'll get w of x divided by 2 equals x minus 2 squared minus 15. Now here's where it gets tricky. I'm going to multiply both sides by 2. But when I multiply both sides by 2, I want to make sure I distribute that 2 to both the squared binomial and the constant. So these 2's will cancel out. I'll be left with w of x equals 2 times x minus 2 squared. And 2 times negative 15 is negative 30. So here's my vertex form. And when I look for the vertex, I find the inside, -2. The x-coordinate is +2. And in the outside, -30. -30 is my y-coordinate. Here's my vertex. And I know that it's concave up because my lead coefficient is positive. As a matter of fact, it's +2, so it's also stretched. So, this is Mrs. Lindsay signing off. Hope you learned a little bit about vertex form and parabolas.